Welcome to Honors Geometry, Lesson 10.5. Other angle relationships. Besides a central angle and an inscribed angle, there are also other ways to make angles relating to circles. And we'll get right at that, how they could interact with each other. How many different ways can a pair of intersecting lines and a circle interact? Well, we've studied two of them already. We studied central angles. Okay, the measure of this arc equals the measure of the central angle. We've also looked at that relationship right there. Oops, let me go on this side where it still continues out. You've got an inscribed angle, and the measure of this angle right here is half of its intercepted arc. But you could also be that it's tangent to the circle, and you could find the measure of this angle or the measure of this angle. It could be that they're inside the circle but not at the center. It could be that it is tangent to the circle at both places. It could be that it's tangent at one and a secant of another. Or it could be that it is two secants. And we'll talk about all those instances today and how to find the measures of those angles. So, let's have some fun. Tangent chord theorem. If a tangent and a chord intersect at a point on the circle, then the measure of the angle formed is 1/2 of its intercepted arc. So the measure of angle ACB, excuse me a minute while I get my little handy dandy slate. Yeah. The measure of this angle right here is half of this arc right there. Okay, it's kind of like an inscribed angle, but not quite. Okay, next scenario, let's move along. And moving along, inside angles inside a circle theorem. If two chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So if you want to try to find the measure of angle, wow, that was a terrible underlining, wasn't it? The measure of angle VYW, this angle right here, you got to look at its vertical angle, that one, and you need to look at the intercepted arcs of both of those angles. So that would be arc VW and arc UX. So the measure of that angle is half the sum of measure of arc UX and the measure of arcs VW. That's when you have angles inside a circle theorem. Next scenario. Angles outside a circle theorem. If two tangents, a tangent and a secant, or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. First case scenario, two tangents. These are going to be tangent segments. The measure of this angle is half the difference. So you've got to take the measure of major arc VUW, and from that you are going to subtract this minor arc right here. Subtract those two and then divide by 2 or multiply by 1/2, and that is the measure. A tangent and a secant. Okay, the measure of that angle is, take the bigger arc. From that, subtract the smaller arc. So the purple minus the black, and then subtract those two, and then multiply by 1/2. And then the other possible scenario is two secants. Alright, this time you got two secant segments, and the measure of this angle right here, you're going to take the larger arc, UX, you're going to subtract the smaller arc, VW, subtract those two, and then multiply by 1/2. Alright, so I'm only going to say this verbally. Okay. If, well, I'll draw it too, but I'm not going to have a separate screen for this. So, if it's a central angle, the arc and the chord are the same size. If the vertex of the angle is on, and it could be either an inscribed angle, or it could possibly be a tangent and a chord. Okay, when the vertex of the angle is on the circle, it is half the intercepted arc. If the vertex is inside the circle, it's half the sum. And if the vertex of the angle is outside the circle, then it's half the difference. Central angle equals vertex on the circle, half. Vertex in the circle, half the sum. Vertex outside the circle, half the difference. Alright, let's have some fun. I'll give you some examples. Okay. In all instances, the measure of arc BC is 60, the measure of arc XY is 80, and the measure of arc BD is 100. So BC, this arc is 60. The measure of the central angle, the measure of angle 1, 60 degrees. Alright, angle 2 is an inscribed angle, that's half of its intercepted arc, 30 degrees. Okay, the measure of angle 3. Okay, if this arc BC is 60, how big is this major arc here? The measure of that major arc is 300. 360 minus 60. So the measure of this major arc is 300. So the measure of angle 3 is half of that, 150 degrees. Measure of angle 4. The vertex is inside the circle. It's half the sum. BC is 60. XY is 80. So 60 plus 80 is 140. Half of 140, 70 degrees. The measure of angle 5. BC is 60. The major arc is 300. 300 minus 60 is 240. Half of 240, 120 degrees. Measure of angle 6. BC, you were told, was 60. BD is 100. 100 minus 60 is 40. Half of 40, 20 degrees. And the measure of angle 7. You were told that BC arc was 60. Arc XY is 80. 80 minus 60 is 20. Half of 20, 10 degrees. Whew. Yeah, I know, I just went through those real quick without you thinking about them. Well, go ahead and replay them and slow them down a little bit so that you can see what's going on there and look at your theorems as you do that. This does conclude Lesson 10.5, Honors Geometry, Other Angle Relationships.